Hey, welcome back to Innovative Creator. Subscribe for more videos. Well, first of all, the initial evaluation images came in the middle of the night, but the team all gathered, and we evaluated whether the camera was working well enough for us to proceed with the alignment. As we analyzed those first photos, the team was pretty positive that the camera was working properly and the instrument was functioning properly. So, we picked a star that was very bright and didn't have any nearby stars that would contaminate the image. We know that the primary mirror segments aren't aligned, so they actually act like 18 separate telescopes. We expect to see 18 separate images, one for each mirror, that are a little bit blurry at this point because we haven't aligned or focused anything. We pointed at a bright star and made a mosaic. We actually took images in different parts of the sky and then looked for the 18 spots from the 18 different telescopes. We were very excited to find them. The 18 spots were actually fairly close to each other, so everything was very close to what was predicted. We've identified which of the 18 spots is associated with which mirror. At this point, we even know which ones are from the wings. And it turns out one of the wings, you can actually see those 3 spots are a little farther over, and that's sort of what we expected. So, we've identified all 18 spots, and the next step is to make an array of them. Then we are ready to start what we call global alignment, which is when each of those 18 spots will start to be aligned and focused. And that's the last step before we take those 18 spots and put them on top of each other to start forming a single star going through the 18 separate telescopes. That's the work we'll be starting soon. We also took a selfie of the primary mirror. We took an image of the primary mirror, and that helps us understand the alignment of the telescope, especially the primary mirror to the camera itself and the instruments. There's actually a special lens in the near-infrared camera that you can put in, and it allows you to take a picture of the primary mirror itself. In this particular case, one of the segments is pointing at a star. So that is the segment that lights up, but you can see the outline through the shadows of all 18 segments. And you also can see the outline of what's inside of the instrument itself, and we can see how well the primary mirror and the telescope are aligned to the instrument. That gives us some initial confidence that the alignment looks good, and that's a good starting point for doing the alignment of the telescope. We have now gotten some data looking through focus, and we've been able to see that we don't see any surprises in the shapes of the mirrors that we are looking at. So far, so good, but we do have a long way to go.